Good afternoon, everyone. Today we're going to continue our lesson on regression analysis for financial relationships. Okay, we started discussing this last time. I'll just have a quick review. For the rest class, please make sure that it will be a not so deep review class because I want you to, on your own, please watch the video. Okay, so the objective is for us to have an appreciation of what was discussed before and move on with the next part of the lesson. Okay, so we looked at what regression is. We said that it's a statistical method in order to establish a linear relationship, a function of your dependent variable, a function of the independent variable. Okay, and in this subject, we're not going to focus on the lessons that's learned in FinArts. Some of you were my students in FinArts, and you'll notice that the discussion here is quite different. It will be more financial related. Of course, the basics will be the same. So last time we talked about linear regression being focused on the dependent variable. I'm pretty sure you know the concepts behind linear regression because you have had these discussions in your previous subjects. So dependent variable, independent variable, okay? And for a simple linear regression, you have only one predictor. So this is the generic equation of a simple linear regression. This is your variable of interest, y. This is your independent variable, and this is your intercept, and this is the slope, which represents the marginal effect on a 1-unit change of your independent variable on your dependent variable. Epsilon sub I here is your residual, okay? Because when you predict using a model, the actual value will be compared to your predicted value, and then any digression, any difference will be considered as epsilon or residual. And the residual is very important. You have to analyze this because if there are certain violations of the assumption of classical linear regression model, then we say that the model ceases to be what we call blue. Okay, we say blue, which is the best linear unbiased estimator. So what is predicted is we would want to determine beta null and beta 1 in this case. If this was a multiple linear regression, you'll have beta 1, beta 2, beta 3, as many predictors or independent variables. But since here we're just having one, we're just having one, then we just have one parameter to estimate, including the intercept. Okay, there are certain assumptions of classical linear regression model. So the method used is ordinary least squares. Okay, the ordinary least squares class come from this one. I'd like to okay, explain. Okay, OLS, no? OLS, ordinary least squares. Okay, so where does that come from? Okay, so let's say you have this is your dependent variable y, and this is your independent variable x. When you create a scatter plot, okay, you have your pair x and y, and let's say you create your scatter plot. Okay, the objective is for us to determine the line that best fits your data. Okay, because this line, which is your y as a function of your x, y is equal to f of x. Okay, as shown here, class. This is your f of x. Okay, we would want that the parameters. Okay, your f of x is defined by your betas, your parameters, beta null, beta 1. We would like the the betas, beta null, beta 1, to exhibit certain characteristics so that they are blue. They are the best linear unbiased estimators. And for them to be blue, these assumptions have to be made. First, let's take a look at how this line is developed or determined. Okay, this line is determined by, so you have your y sub I, this is your actual value. And then we first come up with the estimate prediction, okay, which is your y hat. Your y hat is your predicted value. Okay, and your y hat is actually equal to your beta null plus beta 1 times x. In this case, because we only have one predictor. So the difference between your y sub I minus y hat is the same as the difference between your y sub I minus this one plus. Because this one is your predicted value. And this difference is called your residual. Okay. So if you take a look at this plot here, this is your y sub I. This is your actual value. The dots here are your actual values. The line here, class, is your predicted value. So if I drop here a line, so this one, this is my y hat, or my predicted value. This is my actual value, y sub I. At least for this y sub I, this is my predicted. If I go here on the other hand here, this is my y sub I. Okay, this height is my actual value for this point. And if I drop a line towards the regression line there, this is now my y hat. Okay, in this case, the difference between y sub I and y hat is negative because y hat is greater than y sub I. In this case, here, it's positive. Y sub I, the actual value, is greater than your predicted value. Your predicted values, class, are on this line. This is your line, class. This is your prediction. Okay, your predicted values will all be on this line. Now, the difference between these two is your residuals. Okay, this is your residual. This also is your, this difference is also your residual, epsilon. So if we add up all the residuals, summation of all your e's or epsilons, the answer will always be equal to 0. Okay, some of the residuals will be positive, some of the residuals will be negative, and it will balance out. Okay, so we don't use the summation of your residuals in order to determine your regression line. Rather, what we do is we get the residuals squared. Okay, the residuals squared, class, and this is what we add. Okay, so your residual squared will all become positive. So when we add this, class, it will not be anymore 0. And how is the regression line, class, determined? It's by minimizing your residuals squared. Okay, so let me go back here below. Okay, so these are the assumptions, class, here. The assumptions of number 1, linearity. Of course, dapat the y and x is linear. It doesn't make sense to come up with a model. Suppose you plotted y and x, and the relation appears this way. Okay. If the relation between your y and x appears this way, then this appears to be quadratic, class. So why create a regression line, a linear regression line? Okay, the line of best fit, the line that we're going to create, if your y and x are related in such a way will not be a good estimator. It will not establish a good relationship between y and x because because it's polynomial, or it can be can behave this way, for example. So it seems to be a polynomial, okay? Or for that matter, any other relationship like this one, okay? Or a parabola like this one plus, etc. So if the relationship between y and x is not linear, then stop using a multiple OLS class. That's the first condition. Dapat the relationship between y and x is linear. Also, the independence of terms, the independence of errors. I'm sorry. I need to discuss that. What do you mean by independence of errors? Okay. This brings me to the discussion of three types of data. Okay, so you have, there are many types of data, but for econometric purposes, you have three. You have number one, cross-sectional. Sorry for my writing. I'm using the mouse. My digital pen is kaput. Cross-sectional, and then you have time series. This is time series, and then you have panel data. So please remember this. This is very important, especially when you do your research. You have to understand what the data you're using. Oftentimes, it's for your research, for your thesis. It's seldom that you use a cross-sectional. Can be, but it's more panel data. So let's identify. Let's differentiate class. How do you differentiate between this? You take a look at units, the number of units, and the number of periods. Okay, for cross-sectional data, the number of units is many, okay, and the number of periods is one. Okay, as an example, suppose we're looking at, let's say, insurance companies. Okay, so in the Philippines, there are many insurance companies. So you gather data, and then you have insurance company 1, insurance company 2, insurance company 3, etc. Let's say you were able to gather 80 insurance companies. And you're interested in, let's say, our dependent variable is a net interest margin. Okay? Or let's say ROA na lang, return on assets. All right. So there are many insurance companies, 80 all in all. And then you have ROA for, let's say, 2024. So you have only 1 year. So you have your ROA for insurance company 1, for company 2, up to the ROA for insurance company 80. So what is the structure of this data? You have many units, 80 insurance companies. And what's your period? Only 2024. Okay, only 2024. So if you take a look at this type of data, that's called a cross-sectional data. Okay. Now for this type of data, the sorry, hindi ko na, this is the disadvantage of this one. Okay. The dependence of the residuals, the dependence of your error terms, okay, is of no consequence for cross-sectional data. Why is that so? Okay, so for example, you have, this is your actual value ROA, and then you created a model. Okay, so for the model, you are predicting your ROA. Okay, so let's say this is your actual value, ROA, and then this is now your, after creating your model, you have this ROA hat. hat stands for your predicted value. So you compare, class, your ROA actual, ROA sub I, ROA hat sub I, and then the difference between them is your epsilon. So now you have your column here for ROA, you have your column here for residuals. Now for cross-sectional data, the ordering of the, let's say, insurance companies, okay, does not really come with a logical structure. It means that I can arrange this according to alphabetically, or I can arrange this according to the date it was established, okay, from the earliest to the oldest, or if I can arrange it randomly. Okay, so what am I trying to say here, class? Your residuals, okay, your residuals, of course, if I rearrange it, your residuals will also be rearranged. Because we're trying to determine here, is my residual here related to the residual of of this company, or is the residual here related to this one, or is it related to this one, or is this residual related to this one? Okay, so the structure, the arrangement of your residual will be dependent on how you arrange your bank companies, insurance companies. So if I sort this from randomly, then that will rearrange your residual. So iba na yung katabi plus na mga of your insurance company. Okay, therefore, the arrangement of your residual will be dependent on how you arrange your insurance companies, and usually there's no requirement for it to be alphabetical or whatever, because this is cross-sectional data. It doesn't matter how your data is arranged here. So therefore, class, the question of whether your residuals are dependent on the other residuals is not a question, class. It's not a question because the residual positioning will be changing. However, for a time series data, okay, if on the other hand, it is a time series data, so it's quite different because your time series now will be dependent on one unit and then many periods, many. So you only have one company, one insurance. You have your year here. So you were looking at the ROA of insurance company number one, okay? So this was 2010. And then again, insurance company number one in 2011. And then insurance company number one, 2012. So you gathered data from 2010 up to 2024. 2024 of one insurance company. So number of units, one. Only insurance company one. Number of periods, many, from 2010 to 2024. Okay, so this is a time series class. So that's the difference between cross-sectional data and time series data. Notice that they were reversed. Now, here, class, because the arrangement is based on time, you have only one company here. You cannot possibly put 2015 ahead. Okay, and then just say, I'm going to create a random arrangement, 2015, 2019, 2017, yung feel ko lang, class. Okay, that cannot be, class. That cannot be because the arrangement of the time, okay, there's a structure to that. There's a logical arrangement to your time frame. Okay, therefore, if there's a logical arrangement to your time frame, then there will be a logical arrangement to your epsilon, to your residual. Let's say this is the ROA for 2010. This is the predicted ROA for 2010. This is the residual for 2010. For 2011, the same. So you cannot change the order of your period. And when that happens, class, you cannot change the order of your residual. Okay? So now the question of whether this residual is related to this one, or this residual is related 2 years after, or this residual is related to the residual in 2012, etc. Okay, so that's a plausible question. That's an important question. So that requirement where the residuals, you take a look at the linearity of the residuals, their correlation. Okay, that's important for a time series data. And lastly, also for panel data, which is many. So for a panel data, we have, let's say, let's say, to simplify the example, you have 20 insurance companies. So you have 20 insurance companies for 2010. Then you have 20 insurance companies for 2011. Then 20 for 2012, etc. So these all insurance companies are present in your data from 2010 up to 2024. So you have many companies, 20, and many years. That's 25 from 2010 to 2024, 25 years yan class. So many companies, many years, that's what you call your panel data. Okay. And of all of this data types class, the panel data is the, let's say, is a data that's more flexible in coming up with robust results. Siya yung pinaka-powerful in terms of using it for econometric analysis. Kasi maraming, let's say for example, we can ask, is there a difference between company 1, insurance company 1 and insurance company 2, or insurance company 3? We can take a look at that. Or is there a difference between the ROA of company 1 in 2010 and company 1 in 2011? Nagbabago ba siya over the years? These are questions that cannot be answered by time series or cross-sectional data. So panel data remains to be one of the most powerful type of data as far as analysis is concerned. That's why I said in your thesis, usually what you're going to use is panel data. I haven't seen just a simple univariate time series, unless it's a multivariate time series class. Okay, and that's a different thing. Okay, which I'm not going to discuss here. Okay, so I hope that's clear, class. Let me pause for a while. And is that clear, class, in the difference between cross-sectional and then time series and then panel data? May I have your comments, please? Yes or no, please? Maybe you have some questions. I hope, class, you will respond quicker kasi pag may lag tayo ng malaki, ang dami na nasasayang sa oras eh. For example, ito, baka na naman magtagal yung answer nyo ng abutin kayo ng 1 minute na sayang. No? So, kung pwede, class, I'd just like to commend the other section, yung section 2. No? Pag nagtanong ako, parang popcorn na bigla lumalabas. No? So, maybe it's not... so I hope hindi masyado maglalag yung answers natin. Okay, thank you so much. Okay, so as I was saying here, class, yung independence of errors this is relevant for time series and panel data. Okay, homoscedasticity, this was explained in the video. I will not anymore discuss this here. Normality of errors and multicollinearity. For multiple regression, we don't want that the dependent variables are highly correlated. What we want is the independent variables. In regression class, there's only one dependent variable and many independent variables. We don't want the independent variables to be highly correlated. We want the independent variable and the dependent variable to be highly correlated. Okay, so when your independent variables are highly correlated, you might have a problem with multicollinearity. Okay, and there's a way to check that. So back here, class, to the OLS, which I was discussing a while ago. So let's go back now to our residuals. Okay, our residuals class, diba? Let me just illustrate a few. Okay, so this is residual, this is residual, this is residual. What we said is that we don't add the residuals because they will be 0. What we add, on the other hand, is the squared residuals. Okay, so we square them, class. So it's just like getting the area. Squared residuals. Here is a residual. We square it. Here is a residual. We square it. Okay. And we want that if we add up all these residuals class, we want them to be equal to 0. Sorry, I mistake. We want them to be at a minimum, class. Minimize the sum of the residuals. Okay, and there's only one line where you have the minimum of the squared residuals. That line is called the line of best fit. Line of best fit. It fits your data. Okay, it's also called your OLS, ordinary least squares line. L stands for here, least, the smallest, and squares, the smallest residual squared. Okay, so it's squares. Okay, minimizing the squared errors. Okay, so if we take a look at this one, okay, here class, minimize error squared, which is just the same as, what's your error? It's your y sub I actual minus your predicted value squared. Or your predicted value is equal to your model value, beta null plus beta 1 x sub I for a simple linear regression. So naka-square din siya class. And it should be minimized. Okay? So let's now go here. Okay? Sandali lang class. Okay, so I hope we have loaded this before class. So paki-load tong mga paki-load yung mga packages class. All right. Then okay, thank you. All right. Then here class, of course, I'm not going to explain this anymore because we have already learned about get symbols. Here we're downloading two assets, Apple and then SPY class. Okay. SPY class is this is an exchange traded fund, and it mimics your the Standard and Poor's S&P 500 sa US class. Okay, and there's a reason why we're using this SPY and then Apple. And you know the rest class. I will not belabor. I'll not focus so much on this. But you'll have two assets, SPY and Apple. All right, then here class. So we already have SPY and Apple. Okay, so let me pause for a while. I'm sorry, because I might be going too fast. I'll give you a few seconds class to download the data. And once you're done class, kindly please. Thank you. Thank you, Katrina. Okay, thank you, Therese. Thank you. All right, very good. Salamat sa quick response. I hope the others are able to follow. All right. So there should be no question about this class. I'm confident that you'll be able to get this. Okay, and if not class, please spend some time reviewing our lessons because this has been thoroughly discussed before. Okay, thank you. Now let's generate the returns class. Let's create this object SPY returns. Okay, And then here, we're using return.calculate. You know that this is from performance analytics. From performance analytics. And then return.calculate class. We know that it will generate an NA at the first row class. NA siya kasi wala namang prior value yun. So we get the returns using SPY adjusted, and we will get it from SPY, $SPY adjusted. Method is equal to log. So that's the method that log is the method that's used class, or the type of return used, continuous returns. Okay. For performance analytics, it's method, not type. All right, and do the same for Apple returns. Okay, and when you check your data, view it, you'll notice that there's no NA in the beginning. And it's okay to use this NA omit class at the beginning, because we know that anyway, it's really NA because it has no prior value. Okay, I'll give you a few seconds, please, and then request again to put in the chat box class. Okay, sorry, I had to drop a call. Okay, so okay na ba, class? You have this? Okay, you notice where the code here has already been discussed extensively before. I'm not going to spend much time on that because I'm sure you already know that. Okay. All right, good. Thank you so much. Thank you so much. Okay, kaso 5 lang out of ilan ba tayo? How many are we? Okay, 28. You're 28. So, medyo kulang pa ako yung nang-push yata. 5 over 28. That's not an enviable record. Okay, so let's combine the returns. Kasi meron tayong SPY returns, meron tayong Apple returns. Let's just merge them into one object, combined returns. So merge Apple returns, okay, and SPY returns. Merge natin, or you can use cbind, column bind. Pagsasama natin yung mga columns. So we now have this combined returns, okay? And then you have here all is equal to false. I'll discuss it in a while. Okay, so when you're done, again, please. Thank you, Katrina. So for the others, please. Merge. Tapos gawin nyo na rin to, last, no? Palitan nyo yung column names, Apple returns and SPY returns. And then check nyo kung may sum up nyo all the NAs. I'm sure wala naman yan. And then NA.omit if there are any NAs. Thank you. Okay, very good. Thank you so much. Let's give your classmates a few more seconds. Yes, Kyle, my question.
Sir, should we run it po?
Which one?
Yung tinype po ng...
Oh, iran nyo na. Oh,
Okay po.
iran nyo na siya, ha? Thank you, Kyle. Yeah, please run your codes already. So you should be able to generate this data, combined returns. And then if you run this one, the column names, so dapat magbabago yung column names ng combined returns natin. Instead of apple.adjusted, it will now become Apple returns, no? And SPY returns. And then this one will check if there are NA values there, which wala naman siya, no? So 0 yan. And then NA.omit, that will not result into anything because there are no rows to omit. Okay. Can you still have a question?
Sir, I'm having error po.
Error, sige. Stop ulit ako. Stop share. Okay, paki-share yung screen mo, please. Okay, error. Error. Anong error dito? Walang comma after spy and apple. Dapat may comma yan tao. The after. Yan. After the parenthesis. Oops, hindi. Sa labas ng parenthesis. Yan. Kasi yung susunod mo, source na di ba? Okay. And from, okay. Dali. 2 is equal to. Oh, wait. Nag-run na ba? Kaya may spy and
Yes
apple
po,
na. Okay,
nag-run
good.
na po.
Tapos yung spy returns mo, ano nangyari? Meron na ba?
Yes po, nag-run na
Okay,
po.
good. Apple returns, meron na rin.
Yes po.
Okay, good. So,
Thank you, sir.
thank you, Kyla, for that question. Now, class, ang lesson sa atin dyan, we have to be very careful with the code. No? Ang lessons na shinare sa atin ni Kyle, just missing a comma. So when that happens, class, inspect nyo yung ano nyo. Kasi I will not be there always no, to answer your question. So you have to know when, how to check your code. Okay? So thank you, Kyle. Sige, balik na ako. I'll share again my screen. Okay? So do you have this? Ito, meron na ba nito? Kyle, ano lang paki-remove lang yung raise hands. Yeah, thank you. All right, how about this class? Everyone, you have this? Nag-combine na kayo ng returns? Okay? Minerge nyo siya? Okay, good. All right. Again, if you have questions, please. No? Now, I'd just like to comment on this class. Itong all is equal to false. Now, this should be the last, no? This should be the last option to remove missing values. Okay? We discussed before, I think, the process of imputation. There are many ways to address missing values, and the last one is to remove them. Okay? Kasi, bakit class? Kunyari, we're talking of Apple returns. So, let's say for purposes of example, let's say March 2, NA yung returns niya. Okay, so should we remove that? Not that fast, class. Huling ano na natin dapat yun, option. So pwede natin gawin na tingnan natin yung March 1, meron bang returns nun? Okay? So is it possible to just forward that observation sa March 2? Kasi bakit kaya NA yung March 2? Either baka walang trading at that time. Kunyari baka for whatever reason, class. So if there was no value there, for returns, it's logical to forward the returns on the previous day. That's what you call last observation carried forward, no? LOCF. Okay, so you don't just remove data, just don't remove missing values. Okay? You have to check what are the possible imputation methods for getting for filling up the missing value. Okay, last resort na yung deleting or removing that row. Okay. So we now have combined returns, no? Returns na to ng Apple at saka returns ng SPY. Okay. So this one, class, I give this to you. This is an example of a use of ggplot from the ggplot2 package. And you notice that yung una dito, class, is to define the returns of the data. Now, notice here that it's us.data.frame combined returns. Combined returns, class, if you will check, is an XTS object. Why? Apple returns is XTS, SPY returns is XTS. So, pag kinumbine niya yan, XTS object pa rin yan. XTS objects will not work sa ggplot. So that's why we are converting it into a data frame. Okay. So This one class will not convert your combined returns as a data frame. Okay, only here class in this code it will become a data frame, but your combined returns will still be an XS object. So we have here, okay, so di ba parenthesis, tapos close parenthesis dito. Inside that parenthesis, you have your data and then your mapping. When I say mapping, you define what is your x-axis and your y-axis. Okay, so these are the first two parts of your ggplot. And then you notice there's a plus here. And each time you add a layer class, you have a plus. The plus class should be always at the end of your, okay? So nagdadagdag tayo class ng layer. Here, the layer is, we now identify kung anong type of plot ang ilalagay natin. This is G yung point. Okay, alpha is used for jittering. I just want, maybe you'll just check sa internet kung anong ginagawa ng alpha. It creates a nudge, no? Okay, color is equal to dark blue. And then GG title, you notice my plus dito. Tapos GG title plus X label plus Y label plus, and then theme. Many types of themes. You can check that kung anong iba't ibang klase ng theme. Okay, so when you run this class, you will see this. On the x-axis, you have your SPY. On the y-axis, you have your apple. All right. I forgot to discuss a while ago. Let me backtrack a bit here, class. Okay. Now, why did we use class? Why did we use SPY? And why did we use yung apple kahit anong stock naman to? Pero yung SPY class, bakit? Kasi we are looking at this. I mentioned at the onset that we're going to use top M, di ba? Top M. We're now doing regression using top M. And I hope you remember that your top M is, you're getting it's used for valuation, and the return of the asset is equal to the return of your risk-free rate plus your beta, okay? Beta times your return of the market minus return of the risk-free rate. Okay. So take a look at this. This is your capital asset pricing model. And this is just a simple linear regression. This one. This is your Y sub I. This one, this is your beta null. This one is your beta 1. And the excess returns, return on the market minus risk-free rate, this is your X sub I. There, plus, there. Okay? And notice, as we go on later on, we're going to use this, no? Ang wala pa natin yung risk-free rate. Okay. So you notice, class, that your SPY, which represents your market, is on the x-axis. Now, just remember, class, when you're doing capital asset pricing model, your x-axis should be your market, and then your y-axis should be your asset. Okay? That's why when we plotted this, yung SPY class, yung SPY, okay? Dali lang, class, ha? Yung SPY natin nasa x-axis, and then yung asset natin nasa y-axis. Okay. All right, just to interject that. I'm sorry. Nakalimutan ko i-discuss kanina. Okay, so going here, class. Okay. So in the interest of time, class, I gave this, pero this one, share ko na lang. I don't know if I gave this. Maybe not. Okay. So what are we doing now? We're creating this object called regression data df. You may name it any way you want, you know. And notice that we are converting the combined returns, which is an XTS object. Okay, just so you know, check nyo, class. Combined returns here, XTS object siya, di ba? Okay, but we can't use that class if we're doing LM, linear model. Okay, let me discuss this. So we created this data frame, and then we're going to use it to create our regression, our first regression model. Okay, you have this LM model, and we have LM, our dependent variable Apple returns, tilde, means associated with or regressed on SPY returns. This is our dependent variable, independent variable, comma, and where do we get this? From data is equal to regression data DF. So make sure that you run the first one, class, row 151 in my case. Make sure you run this, and then we're going to create our regression model. Okay, and then here is our LM. We're going to create this object. Okay, let's run this first, class. Run nyo muna yung LM model nyo. Control Enter. Okay, so when you run that class, you'll be generating an LM model. So hanapin yung LM model nyo dito, class. No? And it's a list, class. A list. I hope na napanood nyo na, class, yung ano, malapit na exam natin, no? Okay, so this is your list. So what does your list contain? It's a list of 12 elements. 1, 2, 3, 4, 5. If you count all the elements here, 12 yan. So number 1, andito yung coefficients natin. Ito, class, yung result ng regression natin, no? Yung intercept at saka yung SPY returns. Isn't it that when you create your regression, ang objective is to find out or to solve your intercept and your slope? In this case, our slope is SPY returns. And then, class, ito yung residuals. Residuals, ang dami niya, class. Bakit? You have 1256 observations. You have 1256 residuals. Saan nanggaling tong residuals na to, class? Saan nanggaling dito? Saan nanggaling yan? Nanggaling yan, class, sa, diba, ano ba yung formula ng residuals natin? Yes. The formula of the residuals is yung y sub I natin, okay? Y sub I, this is your, this is your actual value. And then minus your predicted value. Okay, y hat. The difference between this, class, saan nanggaling predicted value? Sinolve natin. Ba beta null, meron na tayong beta null, itong intercept. Plus beta 1. Beta 1 is your intercept, ito, class, ito. 1.19. Okay? Times x sub I. Yung x sub I natin, class, ito yung SPY returns. How many SPY returns? 1256, diba? Therefore, you will have 1256 predicted values. And when you get the difference between your actual and your predicted value, then you'll have your residual. And this is it, class. Now, in the recording, class, diniscuss ko to in greater detail. So please watch that, class. Kasi doon yung maiintindihan, class. At saka yung shortcut kung paano kinocompute to. Which actually, of course, you don't need to compute it kasi ito na yun, na-compute na natin. Binigay na sa atin ni R. And yung fitted value, ito din, class. Ito yan. Ito yung predicted value. Okay? Predicted value. So just by way of getting a sample. Okay. So what is the residual, class, for observation number 1? Kasi each observation, diba, meron silang kanya-kanya silang residuals. So let's see. For the first observation, ano yung y sub I natin? So very quickly, our data is, kunin na lang natin, class, sa regression, ito, class. Diba ito yung data natin, diba? Regression data DF. ito class yung combined returns natin na ginawa nating data frame. And then dollar, kasi Apple returns at saka SPY returns yan eh. So Apple returns, no? Okay? Ito yung Y sub I natin, di ba? Apple returns. And then kunin natin yung first element, and 1. Yan class. So, let's call this Y sub 1. Y1. Yan. Alright. So ano siya class? Okay, nakalimutan ko i-print Y1. I-check yung class kung ano yung Apple returns niya, number 1. Ito yun. Okay? So let's now compute for your pred 1. Okay? So Y pred, let's call it Y pred 1. Predicted value 1, alt minus. Where are you going to get it? From your LM model class. Yan. Nasa LM model natin yan, yung regress natin, yung object na create natin. Dollar. Okay, di ba andyan dyan class yung sa LM model natin? Andyan si coefficients, si residuals, si fitted values yan class. Yan. Fitted values, yan yung mga predicted values. Tapos kunin natin lang yung first one. Okay? There you go. Sorry, hindi ko na naman sinama. Y pred 1. There class. Yan yung predicted value number 1. So if I subtract Y1 minus pred 1, okay? Y1 minus pred 1, okay, that's your predicted value 1. Okay, enter. So that's negative 0.00108, diba? Saan yung residuals natin? Residual to class. Ito, negative 00108. 072. Exact class. Okay. So I hope you watch the video class, no? Soon as sana bago mag next meeting tayo class, please do that para naintindihan niyo yung what's happening here class. All right, so let me go back here. Okay. Now let's take a look at this summary LM model. I'm going to run this. So take a look at this class. Bilis ang oras. Okay. So what's this? So first, it tells us ano yung function na kinuha natin. We use the LM function. Ano yung formula? Apple returns, okay? Associated with SPY returns. And the data that we use is regression underscore data DF. Then we have the residuals. So it tells us the nature of our residuals. We have your 5-number summary here, minimum, maximum. Now, this is important kasi in order for us to determine if our model is blue, we will have to check the residuals. We will have to do what we call residuals diagnostics. Okay, here, it summarizes to us the intercept, ito yung estimate niya, the SPY returns, standard error. Standard error class is this is your standard error of your estimate. Okay, this is just like ito yung average deviation ng actual value natin dun sa predicted value. Okay, and then you have your t-value and then your probability. Take note here that your probability is highly significant. 3 stars. Okay? So ito class, diniscuss ko dun sa natin sa video 1, no? So once again, I'm not going to belabor the point here. I will request you to watch that kasi dinidiscuss ko to in greater detail. Okay. So let's see. Okay. Same thing yun, ano? Same thing here. All right. Now here, i-plot naman natin class. This is just the same as the previous one. Okay. This is just the same as the previous one. And here, okay, may dinagdag ako class. Geom smooth. method is equal to LM. So nagpapalagay ako ng line class, and LM stands for your linear regression line. Okay, so it will insert here the line of best fit. Ito yun. And then you can see here that, okay, and then again, notice plus at the end, GG title, plus XLab plus. The pluses will always be at the end of the code. When you run this class, you'll have this. Okay, this is your regression line. Okay, this is the line of best fit. It's the best line that you can model your your Apple daily returns here. That's what we're modeling, class. Okay, and just one other thing here. Notice that there's adjusted R squared here. Okay, you adjusted R squared, class. It tells us how good is our model. Okay, this is telling us that 63%, approximately 63% of the variation of the variability of Apple returns can be explained by our model. Our model is our variable is SPY returns, di ba? So si SPY returns kayang i-explain 63% ng variability ni Apple returns. What about the 37%? Hindi niya kaya. It means that maybe you have to add more predictors in order to improve this adjusted R squared. Notice I'm not using multiple R squared. Okay? Multiple R squared. Pareho, ito din yung class, no? Multiple R squared. However, adjusted R squared is best used when you have multiple predictors. Kasi when you have multiple predictors, class, if you keep on adding predictors, then your R squared will always increase. Okay? So the more predictors, the higher will be your R squared. But at a cost, class. Kasi, useful pa ba yung predictors na sinasama natin? Okay? So enter adjusted R squared. Where we are penalized for adding predictors that are not really relevant. Okay? That are not really relevant. Okay, so let's go down now here. Bilis ng oras. This one, class, is just a discussion of what I have discussed about class. So, na-discuss naman natin to, no? Okay. Now, yung ano natin, yung betas natin, parameters natin, in our case, yung SPY returns, okay? We're not so much interested in the intercept. We can create, class, we can create the confidence interval. Kasi by formula, ang confidence interval natin is this one. The confidence interval is equal to the estimated coefficient. It's this one, no? For SPY returns, it's this one. This is the estimated coefficient. And then plus or minus. Plus minus critical value times the standard error. So this one, you can easily learn that. I would that you research on how to find the critical value. It's actually easy, no? Isang code lang yan sa R. And then the standard error given na naman. You have the standard error. So that can be easily computed, but if you just want to use the function of R, ito yan, pwede, class. So i-compare natin, class, yung coefficients. Sabi natin, di ba, ito yung LM model natin. Dollar coefficients will print the coefficients. And then confidence interval ng linear model. If you run this, class, you'll have this. So si intercept, okay, 0.003, but actually it's bounded by a lower confidence limit and an upper confidence limit, class. SPY returns, class, is yung 1.89 na to, it's bounded by 1.139 and 1.24. What's important here is that you can see that intercept is touches the value of x. Kasi between negative siya and positive. So possible na tamaan si 0, class. I'm sorry, not x0. That's the reason why it's not significant, class. The value is Hindi ko pa pala diniscuss yung ano, no? Anyway, nandun yun sa ano, sa video, no? That's why I'm skipping some of the discussions because it's in the video, which I would like you to watch. Okay? Now, si SPY returns, notice that it's statistically significant. Why? It will not touch the zero value. So, no, there's no possibility. The possibility is very, very small that SPY returns can possibly be zero. Kasi between 1.14 siya and 1.24, how can that include zero? No? So hindi kasama si zero dyan. That's why we take a look at the SPY returns class. Okay. Highly significant. Okay. Then here, okay, we have time to discuss this. Now, in the discussion of yung adjusted R squared, no? Okay, it's coming from the goodness of fit test. Okay. So, naisip ko kung i-discuss ko yung goodness of fit test na discuss ko dun sa ano, no? And wag na lang class kasi hindi tayo aabot. I want to discuss this. Ito yung mas importante. The goodness of fit test, ito lang yung class. Ito. Here. Ito siya, no? Yung residual error, standard error. Yan. So this is your standard error, standard error of your residuals. Okay. This is just the average, average distance between your actual value and your residuals. Okay? So, my f-stat dito class and my p-value. This means that this is inferential statistics. And there's a null hypothesis here, okay, which I want you to watch na lang dun sa video. No? All right. So, dito class, I want to discuss, and we most probably will be ending here. Okay. In the other class, umabot kami hanggang okay, almost here then. Almost here. Okay. Dali, pause muna ako class kasi baka this is the let's say the price to pay if I'm trying to cover more materials, and I'm fearing that I might be shooting over you, no? Ibig sabihin, useless lang din, salita akong salita dito, tapos ang bilis-bilis ko, tapos hindi nyo pala naiintindihan. That's not the way things should be. So let me, at the risk of sounding too repetitious, may I know class if so far naiintindihan yung mga diniscuss ko a few minutes ago? Clear naman, thank you. Yes, good. I thank God. Kasi sometimes I get too excited and I get too fast, no? Okay, no, yan. Thank you, Kyle, yan. So, Kyle, yes, a question?
I don't think I have po yung SST na code po.
Which one?
Yung SST po. Yung may
Ito,
SST.
hindi ko pa nabibigay, no?
Yes po.
I'll give it now.
Okay.
Okay, sige. Advance pala yung question mo, Kyle. Thank you. All right, sige. Ito, okay. Ito, no, hindi ko pa nabibigay ito, no? Actually, hindi ko binigay sa kabila to. Pero ibibigay ko na. Kasi, para hindi nyo na isusulat. Anyway, naiintindihan nyo naman yan, no? I'm sure that you understand that. Okay, chat. And then give it to you. There you go. Okay. So here we're identifying three measures, class. Why are we doing this? Because I want us to understand, class. Kasi gagamitin nyo sa thesis, gagamitin nyo yung adjusted R squared. You have to know the meaning of that, class. So for example, SST, total sum of the squares, SSR, regression sum of the squares, and SSE, error sum of the squares. Now, there are many names to this. You try to look at references, iba-iba yung pangalan nila dito. Iba TSS, RSS, ESS, yung iba naman U, no? Etc. But what's important is the meaning, no? Kahit na iba yung pangalan. No? Let's take a look at the first one. Ito class, y sub I minus y hat. So what does that mean? We're comparing the actual value and the mean. Okay? So what does this mean, class? Ito class, ang sinasabi nito, wag natin gamitin si SPY squared, si SPY returns. Gamitin na lang din natin yung average ng average ni Apple returns. So this is your base class. Ibig sabihin, we're not going to use our exogenous variable, which in this case is Apple SPY returns. Gamitin na lang natin yung average mismo ni Apple. So si Apple model natin, i-average natin na lang natin siya. So ang projection natin, ang estimate natin, no matter what the value of either your SPY returns, ang estimate natin, yung average lang. Yan, ito class. Okay, so we call that, so what we do is, sorry class, we get the difference, okay, di ba si y sub I natin, marami yan, 1256 yan. So each of them, we get the difference from the mean, and then square it. So once we square it, class, we get the sum. Ganun din dito, class. Ito yung regression natin. Okay? So yung regression natin, class, is i-improve natin si mean. Kasi ang unang model natin yung mean lang. Okay? We improve on the mean by using the forecasted value using, ito class, ginamit na natin si SPY returns. Okay? Dito hindi natin ginamit si SPY returns. Dito, yung y hat na to, class, this is your SPY returns. So this is your predicted value, di ba? Saan nakuha yung predicted value? Beta null plus beta 1 times x. Si x class yung SPY returns. Okay? And then we subtract the mean. So this is actually an improvement on your SST. Okay? So we get the difference and then square and then sum it up. Okay? Ito na yung error or residuals class. Actual minus predicted. Di ba ito yung sinasabi natin? The difference between the actual and the predicted squared class and then sum. That's called your error or residual sum of the squares. And by definition, class, the total sum of the squares is equal to your regression plus residual sum of the squares. Ito yung equation na yun. Okay. So ito, class, ito kasi sana, gawin natin to, class. Okay. I'll just do the first one, class, kasi hindi ko binigay dito sa kabilang section. Kasi gusto ko maintindihan nyo kung ano paano gagawin natin dito. Alright, y sub I, saan natin kukunin? Di ba yung y sub I, nandito yung class sa regression data df. So, ano yung muna class yung regression underscore data? Yan. Regression data df, no? Alright? Regression data df. Saan natin makukuha si y sub I? Apple returns yan. Dollar class, dollar. Ba? Wala. Meron ba akong regression? Ayan, sorry. Ito class, di ba? Apple returns. Andyan, class. So yung buong to class, that's your y sub I. Yung Apple returns. And then ima-minus natin, class. Minus sino? Yung average, yung mean. Mean nino? Mean ni Apple returns. So we just get the mean average nino. Ito class, nito. Control C, Control V. There. It's almost time, class. If you need to go, just go, class. I-continue ko lang to for purposes of recording. All right. So this is the mean of regression returns. Okay. So what are we going to do with this? Yung difference na to, square natin. Lalagyan natin dito ng parenthesis. No? So, ayan. Parenthesis, class. Parenthesis, and then squared. Caret. So, na-square natin siya. No? Pero, class, ang gagawin natin dapat, isa-sum up natin to. Okay? Isa-sum up natin. Alright? So, Paano yung sum class? Diba ganito yung sum? Sum. Ano isa-sum natin? Yung buong to. No? This whole thing. Control C, Control V. Yan. So, kasi marami nalilito class dun sa pag-add ng sum eh. So, pinakita ko lang, sum, open and close parenthesis, whatever we perform nung una-una, ipasok natin dun sa loob. Okay, so ito na yung class. Okay. So, gawin natin itong SSR, alt minus. Okay, so this, SST class, SST. Okay, SST. Sum, itong y sub I minus y min squared. And if we run this class, lagyan na natin dito SST para ma-print din. So this is the total variation class, 0.499. Okay? And then we compute for the regression sum of the squares. So ano yung regression sum of the squares? Lagyan natin dito, Control Alt I, SSR. Okay? Alt minus. So sundan na natin yung formula class. Y hat. Okay? So predicted. Saan natin kukunin yan, class? Diba may LM model tayo? LM underscore model. Ito yung kanina rin natin na regression model. Dollar. Andiyan dyan kasi class yung mga fitted values. No? Asa yung fitted values ito? Here. Fitted values. Ayan. Ito na yung y sub I natin. And then minus average na naman. Diba? Ito yun. Min itong apple returns natin. Ito. Control C, Control V. Mean of the apple returns. There you go. So, tanggalin ko muna to kasi baka malito tayo. Baka malito kayo, no? Oh, sorry. So, we get first the, diba, isa-sum up natin to. Square natin. Diba? So, yan, yung square natin. And then, lagyan natin ng sum, open parenthesis dito, and then close parenthesis dito. Yan. Okay? And then, lagyan natin ng pangalan. This is your SSR, alt minus. Then, print ulit natin. Okay. There you go. So, 0.31. So, actually, class, we can now compute for the adjusted, R squared, which is just, by definition, alt I, it's SST, SSR. Of the total SST, of the total variance class, ang kayang i-explain SSR, yung residuals squared. Regression squared, sorry. Regression to class, ha? Regression yan. Yung na-explain niya. And then if we get this, it's 0.628, which is exactly this one class. 0.628. Yan, 6281. Yan. 6281. All right. So let me end their class. Okay, we're going to continue this next time.